Hello students and welcome to my channel on Maths Hub. So today I'll solve one question that I gave you as a problem in my last video. So I hope you have solved it, and if you have not solved it, so you can check the steps now, right? So the question that was given was a periodic function of period 4 is defined as fx equal to mod x in the interval -2 less than x less than 2, and you have to develop the Fourier series expansion, right? So before we start with this problem, I want to tell you the graph of this function, because whenever the interval is from -L to +L, it is better that you check whether the function is even or odd. And I hope you all know how to draw the graph of mod x. So the graph of mod x behaves like this, and the interval is from 2 to -2 to +2, right? So you can see that the graph is symmetrical about the y-axis. So this shows that the function is an even function. And if the function is an even function, we know that the Fourier coefficient Bn is always equal to 0. So we just need to calculate the coefficient a0 and an. So let us write the formula for an. So for any even function, the formula becomes 2 by L, 0 to L, f of x dx, right? So what is the length of the interval here? The length of the interval is from 0 to 2. So L is 2, so we write 2 by 2, 0 to L. So L will become 2 here, and function is mod x and dx. So you can see that 2 gets cancelled, and 0 to 2. What is mod x? Now we have seen that when we have the interval 0 to 2, mod x is same as x. So we can replace mod x by x and we get x dx. So now integration of x, I think you can do it. It's x squared by 2, 0 to 2. So when I replace here the upper and the lower limit, I'll get 4 by 2, that is 2, right? Now let us calculate the next coefficient, that is an. So sorry, this was a0. By mistake, I wrote an here. This is a0. And the second coefficient that we need to calculate is an. So that is 2 by L, 0 to L, f of x into cos n pi x by L dx. So we get 2 by 2. Similarly, integration is from 0 to 2 mod x cos n pi x by 2 dx. So again, by the same methodology, the interval is from 0 to 2, so mod x is same as x. So we get the integration 0 to 2 x into cos n pi x by 2 dx. Now when we integrate this, what do we get? We get x. So again, you need to apply the Eilert rule first and the second function. So first function as it is, integration of second function, that is sine n pi x by 2 divided by n pi by 2. Then we have minus derivative of x is 1, and again integration of sine n x by 2 becomes minus cos n pi x by 2 divided by n square pi square by 2 square, right? And we put down the limits from 0 to 2. Now what will happen when we put in the limits 0 and 2? Let's see, will any term become 0? So when I put the upper limit 2, so I'll get sine n pi. So sine n pi is 0. Similarly, on putting 0, we will always get a 0, right? So that means when I take out common, minus and minus will become plus. This term will move up. So I'll get 4 by n square pi square. And now when I put in the upper limit, I get cos n pi 2 by 2, 2 cancel. So I'll get cos n pi. And when I put a 0, I'll get cos of 0, which is 1. So this term becomes 4 by n square pi square minus 1 raised to power n minus 1. So I can categorize this into even and odd cases. So when my n is odd, so minus 1 to the power n will become minus 1. So this becomes minus 2. And I have minus 8 by n square pi square. And when n happens to be an even number, then minus 1 to the power n is 1. 1 minus 1 is 0. And so this whole term becomes 0. So then what is the Fourier series expansion? So f of x is equal to a naught by 2. So I'll get a 1 over here. Then you can see that the series only opens for odd number. So in that case, you can replace n with 2n minus 1, right? So we get 1 plus summation n going from 1 to infinity. This is my n, an. So I'll write 8 minus 8 pi. I'll simply replace n with 2n minus 1 square, pi square. And the term here is cos n. So again, n gets replaced with 2n minus 1 pi x by 2. So suppose we are getting values for even number, then you can replace n with 2n, right? So this becomes your answer and we get the Fourier series expansion for mod x, right? So the ones who were not able to solve it, so you can check the steps now, and the ones who have done it already, you can also check your steps whether you have done it correctly or not, right? So that's all in this video. Thank you so much. And if you like the video, do hit the like button, and those of you who have not subscribed my channel, do subscribe my channel to get the latest updated video. And believe in yourself and you will be able to succeed. Thank you.